As you heard, my name is A.Janusz, and the title of my presentation today is Solving Real-Life Challenges by Data Mining Competitions. So it's not going to be about programming, it's going to be about, let's say, alternative way of doing research, okay? So, few words about myself. So I'm an active researcher in a field of data science. I received my PhD in 2014 from the Department of Mathematics, Informatics and Mechanics of University of Warsaw, and I'm currently employed as an assistant professor there. I also work for Silver Bullet Solutions when I'm in a team which is creating a framework for developing artificial intelligence in video games. Okay, so but my today's presentation is about a different aspect of my work. I'm also a co-founder, one of the co-founders of the KnowledgePit platform, which is a host of data mining challenges, and I organized a few of them. So the plan for today is that first I would like to introduce the concept of data mining challenge. So I don't know how many of you have heard about such a thing. So I'll tell you something about it, and I also mention about my platform, a few words, and then I'll try to give you some examples of the data mining competitions which we, with my colleagues, which we organized during the years. So I'll try to explain their scope and research aims and convince you that this is something very useful. Okay, so a bit of a historical perspective. It is difficult to say who invented this idea, the idea of data mining challenges. Okay, so the most recognizable series of such events, I think, is the KDD Cup, which started in 1997, so 20 years of history now. And through the years, the competitions gained more and more attention, and the breaking point was the year 2006, in which Netflix Corporation announced their famous Netflix Prize Challenge. Okay, so they said simply that whoever improves their movie recommendation system by 10% wins $1 million. Okay, and actually after 3 years someone did, and someone took this money. Okay, and another important date is 2010, when the date where when the Kaggle platform was founded. It wasn't the first platform on the market that hosted data mining challenges. However, as we can see now, this is definitely the most successful one. Okay, so they organized over 200 different challenges since the 2010, with the most famous one, I think, is the Heritage Health Prize, with the main prize of $3 million. And they grew so much that in March 2017 they were actually bought by Google. So that means something, I guess. Okay, but what is a data mining competition? So it can be perceived differently from different perspectives. Okay, it's something different to organizers of such competitions and to participants. Okay, for organizers, like a company who would like to sponsor such a competition, it can be a great way of outsourcing their data science research to the machine learning community. Okay, so every company has limited human resources, and they have many projects, so they cannot allocate people to every idea they have. So instead, they can publish their data, open it to the community, and ask them for help, right? And it's cheap because, okay, they sponsor some awards, but only the top-ranked teams are paid in this in the competition. So it's a great way of limiting the research costs. And for the contestants, for participants of a challenge, it's always great experience. Okay, so if the problem is nicely defined, then for many young researchers, enrolling and participating in a competition is a way of learning data science. Okay, so for researchers like me, it's also a publication opportunity. So after the challenge, you can write some paper about it, publish in a good journal, and you received some attention in the community, right? And of course, there are awards. So what do you need to organize a competition? First of all, you need to have a problem which is serious enough for you that you want it to be solved, right? And then you need to have data describing this problem. Okay, without data there is no data mining, right? Then you need to have a person, preferably a data scientist, who take the data from you and prepare it in the way that can be used in a data mining competition. And I'm not going to delve into this problem because I think I would need a separate time slot for that, but it's not always an easy task to prepare the data in a way that really reflects, so the competition really reflects the reality. Okay? Of course, you also need the host of the challenge. It's usually some kind of website which has the functionality of it allows participants to enroll to the competition, register, download the data, and submit their solutions. Sometimes many of those. And it also needs to have some kind of online evaluation system, so the participants could get some feedback after they submit something, right? It's also a good thing to have like some sort of a public leaderboard where different participants can compare their scores, because it stimulates the competition between them and make the in general makes the solutions better. And of course there are sponsors needed, right? Someone has to pay for this. So basic competition schema is very simple, right? You can divide it into 5 points, actually. You get the data and divide it into 2 separate sets. One is called training set, and the second is called test set, right? You make the training data available to everyone, but you hide some targets from the test set, the things that you want community to predict. Participants of the challenge download the data, create their prediction models, submit their solutions, and you need to evaluate those. So you usually take some small fraction of the test data, you compute some scores, and show them to the participants, right? And after the challenge completes, they need to select one of their solutions, tell you that this is their most reliable one, and this solution, only this solution, is then evaluated against the remaining part of the test set, and this final score that it receives determines the rank of the team. Okay? Okay, so well, when I started my experience with data science, I participated in several data mining competitions. I even won some of them. And I always thought this is a great idea. But when I started teaching in machine learning classes, then I realized it would be a great tool for my class, right? To make the students more engaged in the class, right? So together with some of my friends, we started this KnowledgeBeat platform. You can see its address on the slide. And actually, this is not something very big, right, or advanced. It's a non-profit initiative. So it aims mostly at stimulating research in data mining and, you know, to attract students to this area of research. And also we would like to, you know, create some kind of an environment for sharing insights about different problems and exchanging experiences among researchers. So we organize our competitions exclusively in cooperation with some conferences, and at those conferences we organize special sessions where people can meet, discuss their solutions, and you know, tell about the most effective ones. Okay, and at this point, I also need to say that it is all possible because we started a cooperation with the Polish Information Processing Society, and thanks to them, well, they provided infrastructure like servers for this platform to work and stuff like that. So I'm very grateful to them for that. So we organized several competitions so far. We started in 2014, and now I would like to discuss some of them. I don't know if I'm going to be able to tell you something about each of them in many details, but I'll try. Okay, and in this way I hope I will convince you that this is something fun. Okay. Well, we also organize competitions just for our students. Like this is something which we use in our classes as a like semester project or something like that. So those are invitational competitions only. Okay, so the first competition we organized was in 2014, and it was organized in cooperation with the Polish State Fire Service. Okay, and particularly with the main fire service school in Warsaw. So the problem there was the identification of key risk factors for firefighters during their actions. Okay, so data for this competition came from the EVIT system. This is a incident reporting system used by State Fire Service in Poland, and we took 100,000 reports from this system and transformed it into a data set. Okay, so those reports came from many different types of incidents. Actually, from trivial ones like someone has a nest of wasps under the roof and called for firefighters just to remove them, to some serious incidents like fires and major transportation accidents like road crashes and stuff like that. So in the system, each report has two parts. Okay, there is a quantitative part which has attributes such as, you know, how many fire engines were sent to the action, how many firefighters were involved, how much water they used, or things like that. Really, wide range of things they keep track of. And there was also the second part, which are reports written in natural language by the fire commanders. Okay, so after the incident, when they return to base, the commander needs to write some short report, and in this report he or she writes what happened, what was the likely cause, what actions were taken, and so on and so forth. Right? So those are usually very short reports, and it's like free text, so it's very difficult to analyze. However, we managed to extract some features from those texts and created data sets, which you can imagine as a table with 100,000 rows and about 12,000 columns, which corresponded to different risk factors that are associated with different actions, right? So in this competition, the task was not to create some predictive models, but to indicate which risk factors are important and allows to predict whether some firefighters or civilians were injured during this action. Okay, so this wasn't a standard competition. And you know, this was our first competition, so we didn't know what to expect. However, we were able to attract over 100 teams, so we were very happy of that, and we received a lot of submissions. Actually, we received nearly 1,300 submissions, and this was something great because it allows us to do some post-competition research. I'll tell you a bit more about it soon. However, the best results in the competition were obtained using some genetic algorithms to optimize those feature sets. And because we had so many submissions after this competition, we tried to analyze them. So we were looking at associations between different risk factors that commonly appeared in the same sets. Okay, the same sets that were submitted. Okay, and then we showed them to we showed those associations that we found to fire service experts, and it was a great experience for us because most of those associations that we found were kind of trivial, right? So if there is a big fire, there is a higher likelihood that someone got burned, right? And when there is a car crash, very often someone is injured. But some of them were actually not that trivial. Okay, so we found, for example, that one of the most common injuries to firefighters is twisted leg. You know why? Because when they go somewhere for the intervention and they park their car in the night, during the night, where the visibility is limited, they stepped out of the car and twisted their ankle, very commonly. Okay, so we also identified issues related to handling of cutting tools. So firefighters very often need to cut through some walls or some doors. Okay, and it happened quite oftenly that someone got injured in hand because he was holding the tool in a wrong way or something like that. So the result of the competition for the organizers, for the fire service, was that we were able to point some recommendations for the training program of the new cadets. So I think that's something which is useful. Okay, we also organized a different competition with firefighters, and this one was related to the problem of tagging firefighters' activities at the fire scene. Because when there is a fire, this is the huge thing, because there is a fire commander and he needs to coordinate many firefighters that go in different places. They have to they have to the commander needs to know what they are doing. So we thought that maybe we can create a system that would help us in locating a firefighter in a building, and the system would also tell the commander what the firefighter is actually doing right now. Okay, so we prepared our data. So I'll play you a movie of how it was done. So we created a device, a wearable sensory device. We put gyroscopes and accelerometers on different parts of body of firefighters, and we have also this medical belt which was registering vital functions of the firefighter. And we asked firefighters to do some exercises. Okay, so we videotaped those exercises, and as you can see, we tagged them. Okay, so with different actions, like now he's developing a fire line, and then he will be manipulating with the hose, and we videotaped this all, and we created the data set out of it. Okay, so we defined the task so that we want to recognize what the firefighter is doing based on some very short series of sensor readings. Like by short, I mean like less than 2 seconds of series, right? But still, this is quite a lot of data, because 14 sensors generating it was something like 600 readings per minute or something like that. So that was quite a lot. Okay, I think I'll stop that. So we created the data set out of it, and we also asked the community to help us developing good predictive models for targeting those activities. And the main challenge here was, well, not to devise some sophisticated prediction models, because most of participants use the same tools like random forest, XGBoost, and neural networks, all right? But the challenge here is to prepare a representation of that data that would be invariant from firefighter to firefighter, because each firefighters do their activity differently. Like he walks differently, he runs differently. So a very good solution that are tuned for a particular person will not be good for another. Okay, so it was achieved by very nice feature engineering and dimensionality reduction methods. So the best solution obtained scores. This was balanced accuracy of the tags on the level of 0.84. So quite good results. So we also had a series of competitions in cooperation with Innovative Research Center IMAG, which cooperates closely with Polish coal mining companies. Okay, so we were they were interested in solving several problems related to monitoring of safety of those miners underground. Right? The first challenge we organized in 2015 with them, and it was about active monitoring and prevention of methane outbreaks. So you can see a schema of some mining shafts and longwall from one of the Polish mines, and there are some sensors in the corridors, and those sensors measure different things like methane concentrations, for instance, but also they measure the efficiency of the ventilation system. They measure power outputs on those drilling machines and many different things. And the task here was to foresee if the concentration of methane exceeds some warning level during the next 6 minutes. So very short prediction window. However, it's something very useful in practice, because if we could foresee it accurately, then we could prevent power cut downs from the mine. Because currently all those safety systems works like if there is an alarm threshold exceeded, then all power is cut from all machines in the mine. Okay, so the mining stops, everyone goes up, and the company has big losses because of that. Okay, and also this causes those machines to break more often if they are switched on and switched off, because those machines have very high power outputs. Okay, so if we could predict if the threshold will be exceeded, we could slightly lower the efficiency, the mining efficiency at the drilling machine. In this way, less methane is released from the rocks to the atmosphere, and we can prevent this alarm. Okay, so this is something useful. Okay, so we acquired the data. The data consisted of 10-minute long sensor readings. We had 28 different sensors, and on average there was one reading per sensor, per sensor in every second. Okay, so again, here was the biggest challenge for participants was to create methods, prediction methods that would be robust against the distribution drift in data. Okay. And also sparsity of decision classes. This was also something challenging because those alarm levels do not happen very often. Okay, so again, the feature engineering was crucial, and we learned a lot about what kind of features people can construct or create out of those time series of sensor readings. And there actually were very interesting methods of coping with the concept drift. So one of the most interesting, I think, was the thing that, you know, you create many features first, but then you look only for those which are invariant to changes of time. Okay, so you select the features that are very predictive, you know, are useful for prediction, but you eliminate those which are also useful for predicting the time. Okay, because the time is more associated with the drift of the concept than the actual task in this challenge. Okay, and after this competition, the best solution was actually implemented in a decessor system, which is a system for monitoring safety in coal mines. Okay, we also had challenge related to prediction of seismic activity in active coal mines. So seismic activity is something very dangerous in coal mines. It can cause collapses of walls and death of miners. There are also sensors which measure the seismic activity, of course, and we obtained a great data set. That I'll need to say first. So thanks to the cooperation with IMAG, we obtained a great data set from 24 different main working sites in coal mines in Poland. And not only the sensor readings, but also assessments of experts. So every shift, experts go underground and assess the safety. Okay, and this is something which is required by the Polish law. Okay, so we also get those assessments. So this was something very not very common. And we also get some initial geological assessments of the main working sites, so the areas where the mines were located. So I think that because of this data set, it was the most extensive study in this field anywhere in the world. Okay, so we had a training set of 48 months, and we used the following 16 months as this testing period. Okay, but what we wanted to achieve in this competition was actually not a predictive model. Okay, so the task for the participants was to predict those periods of seismic activities. However, we already kind of knew how to do that. Okay, we wanted to check some other things. So we were hoping for the post-competition research, and the topic, the most interesting topic for us in this research would be the cold start problem. So we were asking whether we can deploy some off-the-shelf analytic models to completely new main working sites. Okay, so for those main working sites, we do not have enough data just yet to create specialized predictive models. All right, so we were interested whether we can train those predictive models on different sites and then apply to completely new ones. Okay, so we were also wondering how much data do we need to do that. Okay, so how much data is enough for the predictive model to be reliable for a completely new main working site. Okay, and finally, there was no really reliable study on the performance of expert assessments. So there are some expert methods to assess the safety of the miners and seismic activity. However, we didn't know anything about their quality. So we wanted to check that as well. Okay. and maybe even check whether those automatic machine learning methods can do better. Okay, so this was a very interesting competition because, okay, so to achieve our goal, achieve the possibility of doing this post-competition research, we assumed a slightly different competition model. So we said to participants that, okay, we will grant some data awards to the most active teams. So if you submit a lot and you are active in our competition, you will receive more data from us. Okay, and we divided our competition into 6 phases, and each phase we would release some additional data to the active teams. Okay, so what we wanted to achieve by that is that, like, we hope that people will train their prediction models, do some data science, okay, they will submit solutions, and after they receive some more data, they will retrain the models, submit again, okay, and we will be able to measure the difference. Okay, so those plots shows how it really looked. So those are distribution of scores of the active teams in our competitions in consecutive phases. So the plot on the left is shows you preliminary results, and on the right there are those final scores which were not viable during the competitions. As you can see, there is only very slight difference in performance on this preliminary validation set from phase to phase of our challenge. Okay, so people were able to fit to the small fraction of the test set very fast. However, they did not realize that those performance were not, you know, really that good, and they overfitted to this sample, and it can be seen by the average by looking at the average results, which increase in the first and the second phase in comparison to this phase 0, when no additional data was viable. Okay, so the interesting observations was also that only 20% of teams were actually able to outperform the assessment of experts. Okay, and that was kind of strange because those assessments were available in the data. Right? So based on those results, we were able to create some nice strategy of deploying predictive models to new main working sites. Okay, and learn something about selection of important data chunks, which was also the problem in this case. Okay, so now I would like to tell you about some completely different data mining challenge. So this was challenge which we organized at the beginning of this year, and it was done in cooperation with mBank and T-Bank's company. So mBank was interested whether they can devise some reasonable stock market investing strategy based only on recommendations from experts, so without looking at actual behavior of the market. Okay, so and there are many experts, financial experts, around the world, right? So many of them publish their recommendations online. Okay, so they run some blogs, so they have some home pages where they publish recommendations about some particular stocks, right? So but we don't know which one are trustworthy. Okay, so the T-Bank's company searches through the web and and tries to aggregate those recommendations from different experts. In the data which mBank bought from them, there was 7.5 years of history of recommendations from 2,832 experts. Okay, And we had some additional knowledge about employment of those experts during that years. And what we were interested at was prediction of return classes from particular stocks over a 3-month period. Right? So exemplary entry in our data set would look like that. There was first there was some stock exchange symbol ID, and then there was some list of recommendations from different experts, and then different records have different number of recommendations. It depended largely on the popularity on a given stock. So we had different recommendations, like this expert here recommends to hold, but he or she does not predict the exact return rate. And the 0 here tells us how long ago this recommendation was issued. So at every data record, we would imagine that we need to make some decision about investment, and we used recommendations from last 2 months to do that, right? So we only want to look at different experts and aggregate their recommendations and say whether we should buy or sell or hold. So this was a very interesting competition for us, because even though many participants of this challenge were able to fit very closely to this preliminary test set, the final results were actually not that good. Nobody was able to beat the market. So the strategy in which you would make all this, well, you would not look at the experts and you would always sell, would be able to outperform every machine learning algorithm which was used in this contest. However, it was the cause of that was that people could submit too many solutions, and they tried to really fit to the preliminary evaluation result that they received. So I'm showing you one of the cases. It was the well, the most drastic case, I would say. So here are scores of submissions of one of the teams, which was very active. Those this blue line shows the preliminary results, so the results that they could see after submitting their solution. And the red line here is the actual results, those results which are obtained on the remaining part of the test set. As you can see, if they stopped around here, they could easily win the competition. Okay? But they continue to optimize. And they used some genetic algorithms again to do that, and this was the result. In the end, they were, I think they were in like lower than in 15 franc or something like that. So this was a very bad result for them. Okay, so the last competition I would like to tell you about is the most recent one. This is the competition which we organized together with the Silver Bullet Solutions, and is related to the project that I'm working on right now, the Grail project. Okay. So the task here was to help AI to play game of Hearthstone. I don't know if you know this game, but it's a very popular one. It was created by Blizzard Entertainment, and they reported that over 70 million players, active players, played this game at the beginning of this year. Okay, so huge player base, very popular game. So the rules are very simple. This is a collectible card video game, so the players collect cards, they build decks out of them, and they use decks of 30 cards to battle another player and they use their cards as weapons, spells, and minions, and the goal is to reduce the opponent's hero's health to 0. Okay, so the rules are very simple, but there are many interactions between different hero types and different cards, which makes the game very fun to play and challenging to AI. So the AI which is implemented in that game is rather a weak one. So in our project we decided to use this game as a kind of a proof of concept to show that we are really able to create challenging artificial intelligence in games. So we implemented a simulator of this game, and we used some artificial bots which were not very intelligent. They made random decisions just to generate a huge data set. Okay, so we generated, we simulated many games, and we generated a training set of 4 million game states, which we used in our challenge. Okay, so the task for participants was to predict whether at the given game state of the game, so you can think about it as like you look at the board, Hearthstone board, and you see what cards were played, and you have to predict whether you are going to win or lose the game. Okay? So challenges here in this particular competition was to devise a nice representation of a game state. So we made available, what we made available was just JSONs with some structural logs describing the game, but such an input cannot be used directly by predictive algorithms. So people had to devise some representation, which was the challenge here. Okay, so in the end, it turned out to be very popular competition. We attracted nearly 300 teams from 28 different countries. So here are some of the results. As you can see, they were measured using error under ROC curve. So the results on the level of 0.8 are quite good. And that shows that it is really possible to predict whether who is going to win just by looking at the current game state. Okay, so but for us it was interesting to also check whether knowledge extracted from those weak players can be used to predict results of games between challenging opponents. So we implemented also more intelligent bots using the MCTS algorithm, and we generate data using only those bots, and it turned out that those models trained on games between random players are also pretty good at predicting the outcomes of those more advanced players, of the games played by those more advanced players. So that's something interesting, I think. Okay, so now we are working to integrate those machine learning methods and game state search heuristics like MCTS in order to create a very efficient Hearthstone player. So to conclude, I hope that I convinced you that data mining challenges can be very interesting, and they can be very useful whether you are a participant or organizer of such a challenge. It's actually kind of a win-win situation where both sides have some advantages, have some benefits out of it. So for companies, it's a way of outsourcing their research and reducing the costs, but also a way of finding potential employees, right? Because they can contact those who made some interesting models or had some interesting ideas, and they can start to cooperate. And for participants, it's also something great because you know, it's kind of, at least for my students, it's very often like they start paying attention to the things that are in a class. Okay, so they can see that those things are really useful for them. And you know, this is also a great source of topics for their master thesis or doctorates. Okay, and also, as I mentioned before, for many young researchers, competitions can be a great way to learn data science. Okay, learn it in practice. Okay, so that's end of my talk. Thank you very much for your attention.